Okay, in this screencast, we're going to put into practice the ideas that we reviewed in screencast number 1. Now, the big tip here is that whenever you do encounter a situation where forces aren't in the same direction, where there's a force that's got multiple directions, what you want to do is use your SOHCAHTOA relationships to resolve any of the uncooperative forces. So that's forces that are not, say, already on an XY axis. So if it's at 35 degrees, it's not on X and Y. So let's get rid of it and replace it with the two forces that are on the X and Y axis that would add up to what it's equal to. And another important element of that is once you've done the conversion, ignore the uncooperative force. Get it out of your diagram, scratch it out, mark it off. Don't also use it because then you're putting in too much force. Okay? So we're going to use the same object we had before, which is 2 kilograms of mass, 19.6 newtons of weight. So the mass of our object again is 2 kilograms. And we're using a 13 Newton force at an angle of 23 degrees. We already figured out that meant that refer back to video 1, the X component is 12 newtons and the vertical component is 5 newtons. So once I've done that, I'm getting rid of this force. It's no longer part of the situation. If you'd like, you could then redraw the 5 Newton vertical force over here, or extended from here, anything that helps to line it up. Make sure you understand that it is coming out of the center dot at that point. Now what I have here is a situation where I have an unbalanced force of 12 newtons to the right. Now I'm going to need, since it's on a horizontal surface, there is a normal force, I'm going to need this force, the weight, to be canceled out by the combination of the normal force and the vertical force that we're pulling up. So by lifting upward, we're taking some of the weight off of some of the normal force off of the surface. And that difference between those two, they still have to add up to 19.6. So I have 5, so 14.6 plus 5 would make 19.6. Now again, all of those are going to end up canceling, and our only force left over is the 12 Newton force that we had in the original video. And to get the acceleration, we're going to take the force divided by the mass. That's 12 newtons divided by 2 kilograms, and we're still at 6 meters per second per second. So we have a slightly different force, a larger force at an angle, and yet we get the same overall result as we got before. This time we're back to using the 8 Newton force that's a friction that's working against us. Again, this is 5 newtons and this is 12 newtons. This goes away. This 5 Newton force is acting upward in concert, if you will, with the other force here. So 5 plus 14.6 will make 19.6. Again, these will all end up canceling each other out. So we're left with 12 to the right and 8 to the left. So our net force, which is also means to add all the forces. If I say to the right is positive and to the left is negative, it's going to be 12 newtons positive plus a negative 8 newtons, which is a leftover of positive 4 newtons. 4 divided by 2 is going to give me 2 meters per second of acceleration. Again, that's to the right, as was the force. These two, the force and the acceleration, are always going to be directly proportional by the second law of motion, the law of acceleration, and therefore they will always be in exactly the same direction. Okay, so that's the basic process. No matter how complex the situation becomes, if we eliminate any cooperative forces and replace them, you can't just take them away, replace them with 2 perpendicular components that add up to that one force, then we can get all of our forces on the X and the Y axis. We can quickly and easily cancel out whatever cancels out. We can figure out what's left over, and then we can go ahead and calculate our overall acceleration. Okay, so we'll get some more practice in with that with video number 3 in a bit.